Hello guys, this is the second tutorial. So now we are going to look at what happens when you are required to include compression reinforcement in your design. So now we are given that the design ultimate moment is 285 kilonewton per meter, and we are required to find the area of reinforcement given the same information we had from the previous example. So now again, where you start by calculating your k. So my k in this case is 285 times 10 to the power 6 divided by my b, which is 260, times 440 squared times 30. Let's see what we get in this case. So now I have 285 times 10 to the power 6 over 260 times 440 squared times 30. Okay, so now we get 0.189, which is greater than 0.156. So in this case, compression reinforcement is required. Okay, so now I'm going to go to the code book. Remember, we're doing structures in this case, so everything you do is in the code book there. So now I'm going to check on my code book. What does it say when you have? They say that if k is greater than k prime is your 0.156. It's there. K prime is your 0.156. So now if it's greater than your 0.156, the tension and compression reinforcement are required. So we require both so that this thing can be able to stand. So now the next thing you do, we are going to calculate our Z using that K prime. So to do that, we're going to calculate our Z using K prime. Okay, so my Z is D into 0.5. Right, let me copy 0.25 or 0.5 plus 0.25 minus k prime over 0.9. This is rooted. So now I have to calculate my Z will be D into 0.5 plus the root of 0.25 minus k prime is 0.156 divided by 0.9. So my Z, what do I get for my Z? I get 0.5 plus the root of 0.25 minus 0.156 over 0.9. So now I get 0.78D, which is less than your what do you call your 0.95. So it's okay. This is less than your 0.95D, so it's okay. Alright, so now I'm going to calculate my area of steel, of compression steel. So on the code book they say that area of compression steel, it's given by the area of compression steel. Remember, if you want the abbreviations, you can find them here. So this is the area, the AS prime is the area of compression steel. So now we are going to find the area of compression steel. So area of compression steel equals to your K minus K prime close bracket times FCU times BD squared divided by, here you can see that on the code book it says divided by FYC multiplied by D minus D prime, but there is a formula that I'm sure gave you on the slides, a simplified one. You can just use 0.72 Fy D minus D prime, so nothing really changes. It's only that you simplify FCY, which you can look up on the abbreviations and simplify. So now I'm going to substitute my K prime. My K is 0.8189, 0.189 minus 0.156 K prime times 30 times B, which is 260 times 440 squared. This is divided by 0.72 times 450 times my D, which is 440, and then D prime is given on the question. That's the thing that we didn't have for question 1. D prime is what? Is 50 there. So it's 50 minus 50. So now I'm going to find the answer there. Okay, so the answer will be 0.189 minus 0.156 times 30 times 260 times 440 squared, 0.72 times 450 times open bracket 440 minus 50 close bracket. So the answer I get there is 94.37. These are millimeter squared. So we found the area of compression reinforcement. So now we need to go back to the code book. Remember, you are doing structures. You go back to the code book whenever you want something. So now we want the area of steel, of reinforcement steel. We want, this combines everything, the area of your steel plus the area of your how do you call this, plus the area of, we are going to add the area of steel plus the area of your compression reinforcement, the area of tensile reinforcement plus the area of compression reinforcement. I think that's the way I should put it. So now again, I'm sure there's a formula, a simplified formula that would gives, but you can still use the one on the code book. They all give you, this is C, give you the same answer, PD squared over 0.87 FYZ plus AS prime. So you add the compression reinforcement, so it's a combination of two. All right, so now my KU or K prime, as I was taking it as K prime, so it's 0.156 times 30 times 260 times 440 squared divided by 0.87 times 450 times my Z. Where's my Z? My Z is here. Is 0.78 times 440 plus 394.37. So let's see. Now we're going to have 0.156 times 30 times 260 times 440 squared 0.87 times 450 times 0.78 times 440 plus 394.37. Okay, so now my answer, I get 2147.63 millimeter square. So that's the end of this question then. Thank you.